Hello, everyone. Welcome to the XR Bootcamp Hand Tracking and Advanced Interaction Masterclass Open Lecture. Today, we are excited for multiple reasons. One, of course, we have Julia Schwarz, who is the most influential person in the industry for hand interactions. So we would like to welcome her, and Rene, who is the moderator today, that will take questions from Zoom and from the Zoom link that we have the lecture today, and he will also receive the questions from the Slido from our experts group. So we are also excited because there's a huge interest. We knew that hand interaction will become an industry standard soon, but we have seen that there's already 1,200 signups for today's talk. So we hope that you will enjoy this open lecture. One thing that I would like to mention, this will not be the last one. We have multiple open lectures that we are planning. We want to show you how our typical masterclass looks like. So happy to see all our participants here. We have masterclass students that they will actually ask questions directly. We have our advisory board from the industry, especially from enterprise and from vendors. And we have also all the stakeholders of XR Bootcamp to enable this one-to-one Zoom discussion. After we have Julia's presentation finished, we will start the Q&A session. We expect over probably an hour for this session, maybe 1.5 hours, just to share with you beforehand that probably in 30-35 minutes, we will start the Q&A after the presentation is over. A few important maybe notes that would like to maybe for those who wants to join our master classes and the expert group. As I mentioned, we want to create awareness on hand interaction, and we created an expert group. There's already over 150 experts from industry, research, and different areas, like even freelancers and students are even joining to this group. We want to facilitate the exchange of different projects and knowledge each other. And then we would like to also create some kind of like a opportunity for these experts here and our trainers, Hand Physics Lab. Also, they are sharing quite exciting versions before anyone else here. So we are happy to welcome all our expert group today. And if you want, you can also join. It's an open group. Our team will share on YouTube how to join to this expert group. And in addition to that, what is this masterclass about, right? We are mentioning about the masterclass. Actually, we have multiple masterclasses happening in the upcoming months. One of the masterclass will be also, again, we will open another hand tracking masterclass because it's quite interesting for most of the industry right now. So it will start on October, and it will be also again an 8 weeks program with all these different features and lessons included. Our masterclass students, you will also have the chance to meet with them, or our lectures will be also today, maybe asking questions to Julia, interesting questions. So for newcomers and new starters, we have also no coding required or VR knowledge, AR knowledge required classes that we are also enabling with an AR remote support application. It's an enterprise level application with AR Kit, AR Core included. We hope that with a mixed reality headset enterprise application scenario, we would like to also open a masterclass for especially for this field. We are quite excited to work with the headset manufacturers and industry partners to enable that. And our last masterclass is much more on the enterprise side, that we are actually bringing two different target groups. On one side, there will be enterprise level people who have maybe limited coding knowledge or only design knowledge, and they are bringing the scenario. The other part will be VR developers or XR studios who actually join forces throughout this training simulation, that they are actually creating a VR training scenario, a real industry scenario at the end of 4 weeks. So I think for today, you are for Rene and Julia, so I would like to leave the stage to them. I would like to thank everyone again, all our partners, to make this happen. One last maybe note, that we will actually make this lecture available closed captions to make it accessible. So I just want to inform about that. And I hope that you enjoy, and stage is yours, Rene and Julia. Thank you.
Hey, thank you, Farhan. Hi, everyone, also from my side. We will shortly start with Julia's session. I just wanted to introduce her. You probably know her already from the MRTK and all the amazing work she does for the HoloLens and the HoloLens 2 as well. Julia is a principal software engineer working on the HoloLens team. She has been doing human-computer interfaces since, well, quite a while, in fact, and also researching, but also implementing things. So she combines like both things, like researching and implementation, which is a really unique skill. And she's also an amazing presenter, and you might have actually seen her presentation at the MWC Barcelona when the HoloLens 2 was unveiled. Maybe we get to see like a little piano today again. I don't know. But anyway, that was awesome. Real quick, my name is Rene. I'm a Microsoft Regional Director and the MVP. These are community awards that Microsoft provides the independent experts. So I don't work for Microsoft. I work actually for Valorem Reply. And we're a digital transformation company working with the HoloLens since 2015 or something like that. And I will be moderating the Q&A session, which we will start right after Julia's talk, like maybe 30 to 40 minutes or so. And like Farhan mentioned, so if you're part of the expert group, you should have gotten a Slido link where you can type your questions. And for the folks that are in the Zoom meeting here, please use the raise hand feature, and then we will promote you to be a panelist, and then you can actually unmute yourself and ask your questions directly. And we can keep it a little bit more interactive than just like reading questions and, you know, trying to get them answered. All right, folks, thanks again for joining. And now, Julia, take it away.
Okay, Rene, thank you so much for having me. It's really great to be here. Let me go ahead and start the slide share here. I think if I do that and then start the presentation. Does that look good on that end?
Looks great. Right. Looks great.
Okay, super. Great. It's really nice to be able to actually, you know, share all of this work remotely. Back here in America, I'm still sitting in working from home. So it's really awesome to be here and share all this knowledge with everybody. I also wanted to really thank my colleagues at Microsoft who are allowing me to share all of this work, and really have been for the last year, to share all of this knowledge. It's actually really great that I'm allowed to talk about all of the prototyping and the work that we did to ship Instinctual Interactions on HoloLens to basically spread the knowledge and make all of you better, so that you can become better prototypers yourself. So I'm really happy to be here and share all this information with you. So today I'm going to talk about all of the prototyping and the work that really went behind actually shipping Instinctual Interactions for HoloLens 2. And I'm hoping that by the end of this, you can get an understanding of all of the experimentation that we did to actually get where we are with the HoloLens 2. And also, I'm hoping that you can learn some tips for how you can improve your own prototyping with this. So let's go ahead and get started. I always like to start these talks by reminding ourselves what an incredible time we live in, because many of you probably can remember all the sci-fi movies that inspired you to work on AR and VR, where you could, you know, reach out and touch light and holograms in front of you. And that's not really science fiction anymore. As you can see here in this video, this is just a see-through capture of the HoloLens 2 headset. So this is basically a rendering of what I see when I can, you know, reach out and touch and manipulate holograms. So this sort of things of movies are now actually real and things that we can do. And it's really an incredible time that we can basically be here and do this and work on this area. And the reason that I look so excited in this presentation that we gave for the HoloLens 2 just about a year and I guess a year and a half ago now, is because I am really thrilled to be able to basically have gotten to spend the last 5 years trying to make this dream a reality and then get to share it with the world. And I wanted to mention one thing, which is that we're just at the beginning of all of this, that we're really in the Wild West of sort of 3D interfaces. There's been a lot of research over many years to try and sort of improve and come up with interaction techniques, but we're just getting started. And actually, it's going to be up to all of us and all of you watching to make all these improvements. And so what I'm hoping is that, first of all, you approach everything with an open mind and don't just take what I'm saying and say, oh, well, Julia said to do it this way, so I'm not going to do it this other way. No, you should absolutely experiment. But what's also important is for you to know all of the work that has come sort of before you, not just from the things that we've done, but from all of your peers and from all of the research that's been done over the years. So sort of keep an open mind and always try new things, but also be aware of the work that has been done so that you can sort of use that to build your own mental model of what can work and what can't work. So today I'm basically going to do that. I'm going to share with you many of the prototypes that we worked on to actually get to HoloLens 2. Just to give you a ballpark number, we built roughly around, I would say, around 100 different prototypes or iterations of prototypes, various projects. For most of those, we actually wrote a little report internally where we would kind of write down what we did and what feedback we got from people, what worked well and what didn't. And the general approach was, and this is what I mentioned in my HoloLens 2 announcement video, because it was the truth, which is always, always nice, is that we basically tried as many things as we could, and we looked at what worked and what didn't, and we sort of, narrowed in on what worked and kept sort of finding out things don't work. Okay, we'll do those later. So without further ado, that was generally the approach. Let me just go ahead and dive right in to all of the prototypes that we worked on. And I'm going to break it up into several parts. So I'm going to first talk about near interaction, and then I'm going to talk about far interaction. So far interaction would be interacting with objects that are not within arm's reach. And then I'm actually going to talk about how the sort of overall learnings that we've had, how we're translating that into tools that Microsoft, or that we're all working on, such as the Mixed Reality Toolkit, which is an open source project. And then finally, I'm going to talk about various tools available to you when you're doing prototyping to make your iteration times faster. So I want to start off with the very first HoloLens application that I actually ever built, which was this Minecraft cube. And like many of you, I was, just picking up HoloLens and Unity. And I'm sure many of you sort of were in that boat. And maybe you can remember the first thing you built. This was actually the very first thing that I built. And it's so rare to build something and have it be a huge hit. Most of the time when you're building prototypes, you build something and it's kind of like, it's okay. People are kind of excited about it, but sort of this one was really unique in that people had never really experienced reaching out and touching a hologram like this before. So the reactions that I got when I showed this to people was really incredible. And it's interesting that, when you get that to be your first prototype, it kind of, it's at the same time very lucky, but also you get your sort of calibration completely wrong, because then the expectations are incredibly high. But let's focus on what about this prototype worked and didn't work. So one thing, this wasn't the first sort of prototype of sort of the idea of touching holograms with HoloLens 1, but there were several things about this one that sort of made it stand out relative to other prototypes. So I should also mention that back when we were working on HoloLens 1, for folks that aren't familiar with HoloLens 1, it's an AR headset where sort of the way that you interact with it is you have a cursor in the middle of your head, which is actually very accurate because the HoloLens 1 head tracking is extremely good. So it's a fairly accurate cursor that you sort of that's your mouse, and then you click by doing sort of this air tap gesture. And that's what everyone was used to. And in fact, the idea that you could get close to a hologram was very, very controversial. In fact, they had a clipping plane. In other words, when you got near a hologram, it would actually fade out and disappear. So I was just sort of tried to take that idea and flip it on its head and say, well, what if we remove the clipping plane, and instead of your head being the targeting, what if your hand was the targeting, and then the click was just the sort of the air tap gesture. And this is sort of what came out was the Minecraft cube idea. Now, I had seen some people do prototypes similar to this, but one thing that they did that was different is instead of directly moving the vertices, they would scale the entire cube. Now, it's actually really important that the vertices were as close to the hand as possible. I actually removed all smoothing from this and made the vertices follow the hand as closely as possible. And the reason for that is that it actually feels, the result is to make the hologram really feel connected with your hand so that you really feel like you're touching the hologram. So that was one thing that was important, was try to sort of remove all sorts of variables that would make the hologram not feel connected to the hand. Now, the next thing here is you don't hear the sound because I removed it from the video, but there's actually going to be a sound that plays when you pinch down. And you can also see a visual change in the cubes. So basically when the grab starts, then you see the cube turn a darker color. There's a lot of those little details in the design of a demo that actually can make a massive difference in how it turns out and the way that it's perceived by people. Sometimes you can have two almost identical prototypes, but one just spends more time giving feedback to the user. In other words, visual and audio feedback. So the cube changes visual color, and I play a sound to let the user know that the system thinks that the user has grabbed the hologram. So my hope is that one of the big learnings that you take away from today is to always add visual and audio feedback to your demos, especially because with AR and VR interactions, it's even more prominent in AR. You are basically touching the air. So there's no physical sort of haptic feedback in many of these systems, although it's a very interesting area of research. So you need to compensate for that by visual and audio feedback. And I'll be repeating that idea many times. So those are the things that worked in this demo. We sort of removed all of the things that we made the hologram feel as connected to the hand as possible, and we added audio and visual feedback. Some things that didn't work when we tested this is that people actually had a fairly difficult time grabbing the corners of the cubes. And this is because they didn't have any feedback whatsoever in this demo for when the hand was near the cube. So I had actually tried things like a hover state. So when you hover near it, the cube gets bigger, but that actually didn't work as well because you wouldn't quite know where your hand was in relation to the hologram. So the learning there, which you'll see later on in the demo, is to provide visual feedback that sort of gives you a sense of where the sensed hand is in relation to the hologram. So in the mixed reality toolkit and in HoloLens, we have sort of a luminous lighting effect, where as your hand moves around a hologram, you can kind of tell where it is relative to that. Okay, so from this, what we kind of got the idea about is that, okay, touching holograms is obviously a very, very powerful idea, and it would be really fantastic if we could sort of make this a reality for all of our customers. So then, okay, so pinching is good. Well, what about other things? What about, sort of pressing buttons and interacting with other UI controls? So that's the next big prototype that I want to share with you. This is actually the prototype that I was talking about in the Mobile World Congress demo when we sort of had that panel and we talk about sliders and buttons. That's literally this demo. So what we did here is, again, we did sort of what I call the shotgun approach, which is we think of as many ways as possible to interact with 3D controls, 3D UI controls, buttons, sliders, things like dials. So we thought about both sort of pinch type interactions, press type interactions, rotational interactions, and so on. And we built all of these to sort of a level of quality where we tried to make it feel as good as possible. Obviously, the visuals, I'm not a visual designer, but I did have some design help from some of my collaborators to get those nice icons. But the key is to make the interactions feel good. There's a difference between visual polish and sort of interaction polish, and interaction polish is actually very important. So what we learned from this when we showed people was that people really liked pressing buttons. They sort of, that one, even in its very primitive state without any sort of lighting feedback, that performed quite well. Actually, the push slider, the one that you see there, didn't actually perform nearly as well, most likely because of sort of reliability issues. And also the pinch style interaction. So when you kind of pinch the slider, move it, that performed well. The pinch and circle worked well as well. Things that didn't work so well were things sort of like the dial where you would grab it and then sort of rotate it. And the reason for that was that with a physical dial, you have a physical barrier to stop your fingers. But when you're sort of interacting in the air, you have to frame the dial with your hand somehow. And then as you move, your fingers actually sort of move inside the dial. And that can actually make it quite difficult to track. So this is sort of another learning when thinking about interaction design for AR, is that this is a computer vision based system. So if your HoloLens, if you can basically see your hands, then roughly your HoloLens sees them. But if your hand is sort of in a position where you can't see your fingers, the HoloLens also doesn't see it. And it's not really going to know what your fingers are doing. So when you have an interaction where you sort of rotate your hand, that's actually very difficult to track and is quite noisy. Not to mention that it sort of doesn't actually feel so amazing because you don't quite know when to stop, when your fingers stop for the grass. And that's sort of why the pinch interaction feels so good, we think, is that there's that, we call it like self-haptic feedback. So your fingers are touching, so you get that fake haptics for free so that you know sort of when an interaction starts and ends. Okay, so what are sort of the higher level ideas that we can kind of get from both of these prototypes? One is quite simple. Actually, many of these are simple, but that's actually a good thing because you kind of want simple ideas. If you have something that's very complex for interactions, then it's hard for people to do. So many of these things are simple ideas that have a lot of implementation details under the hood to make them work well. So if you see something that looks like a button, you should be able to interact with it by pressing it. That was one core idea that we had for HoloLens 2. And another one that's related to the Minecraft cube that I talked about. It actually was less, we got a lot of feedback in the UI controls prototype that there weren't enough visual and audio cues. Basically, sort of when my hand got near the button, it lit up a different color. That was not strong enough. People really wanted more of that luminous effect. So it's very important, though, to use visual and audio cues to communicate when you're near an object, when you're touching it, and when you're actually moving it or manipulating it. And just to give you an example of that, for how that's actually used in sort of the mixed reality toolkit, is you can see actually the buttons, there's a lot of work that went into these buttons, a lot of little details. So you can see that lighting effect. You can see the finger cursor, which I'll talk about later. This is in Unity, by the way, using the in-editor hand simulation, which means you don't need a HoloLens or even hand tracking device to test these things out. And you can see all those little details about sort of as you contact, you see a pulse effect on the button. And when you move in, there's a cage that kind of moves in with it. All those little details are what make this interaction successful. And I think that from these prototypes, we learned that when you don't have them, that's actually can really be a challenge. Okay, so we've talked about sort of UI controls and pressing things. How about moving things? So to sort of understand how can we manipulate objects using sort of direct interaction, we of course built the classic, this is something that pretty much everyone wants to do first, is grab an object and rotate it with your wrist. And then another thing that everyone wants to do is to add sort of push type or physically based interactions. So we tried that as well. And for each of these, we sort of had a task that we wanted people to do, which was to get the screen or get the crane inside the box with a certain rotation. And I'm going to talk about that in a minute and the importance of that. So from this, we learned a couple of things. One is that it feels really great to be able to grab something and rotate it using your wrist. But it can actually be quite difficult to be super precise with that. So if you need to rotate something within 1 or 2 degrees of error, it's going to be very hard because as you release, your wrist, the sensed wrist, is actually moving. And this is kind of a theme for many interactions that that you sort of, as you go and design these with vision-based systems, is that you want to come up with interactions and algorithms that work well for the computer vision and the sensing system that you have. So even if your real hand doesn't move that much, the vision system might think that. So you're sort of always trying to find a balance between what can the hand tracking sense and what's going to actually work in the interaction. And a lot of it's really about coming up with algorithms that work well given the current state of hand tracking. And then, of course, as hand tracking gets better, constantly revisiting things and improving them. So wrist rotation, great for sort of inspecting, really difficult to be super precise with it. There's other techniques to have precise movement and rotation. for pushing objects, that can feel really good. However, it can be very hard to again, precisely position an object. So because I was working on the shell team, so the team that builds the general UI, where precision, basically what's important is consistency and precision. So I need to be able to exactly position things, and it needs to work in a broad range of cases. We sort of didn't want to have everything be free form and floating, because then your edge window was going to fly away, which is great if you're in a game, but maybe not so great if you actually need to enter a website or something. So what did work well, though, is if you constrain the rotation. So for example, with the push example, if you keep the position still and you just rotate it about the y-axis, that can actually feel quite good. So again, here what we see is we're trying many things and we're finding out what is and isn't working. It's usually not black and white. Usually you'll try something, and in it you'll learn many things that don't work and then a few things that do work. One thing I wanted to leave folks with in this class, since it is a class and I'm hoping that you're learning things from it, is the importance of giving people a task when you're actually building your prototype and sharing it with people. So it's something that I see often when I have many engineers that I work with who don't have a background in prototyping. They will, if they had built this demo, they would just have a crane that you can pick up, and that's it. But actually, when you do that, it gets to be very difficult to actually get good feedback from sort of people, because what they'll do is they'll kind of play with it and they'll say, oh yeah, that feels great, good job. But when you give them an actual task, when you say, oh, can you put that in the box? Then what you find is that people start really picking apart and explaining to you what is and isn't working. And actually, they'll often find more breaking cases. What you really don't want is for people to sort of say, oh, that feels great, and then sort of move on, because then you don't learn much, unless it's really an incredible prototype. But even the best prototypes, there's things that you can improve. So give people a task to do always in your prototypes. And another thing that I don't remember if I mentioned explicitly in the slides, but it's also very important to, when you're prototyping, to share your work obviously frequently with your peers and with your friends, and to just approach it with a notepad, paper, or your phone or whatever, and just listen and observe and say, how does this feel? How does it work? I see a lot of people often sort of getting defensive in their prototype and explaining, well, that didn't work because it's not done, there's a bug. I know why that doesn't work. That's not what getting feedback is about. Getting feedback is about getting feedback, listening. And that's actually how you're going to improve your prototype, is by observing what is and isn't working and learning from that. So make it so much more about a discussion about how it feels and not about the quality of the prototype itself. So I just wanted to make sure to get that out there, because I think that's something that will really improve all prototypes and all sort of work, is if we just focus on learning from the artifact and not on saying why something isn't working. Okay, so from this prototype, we get the general idea again, that wow, grabbing things directly feels great. And it's very interesting in this picture, you can see that the size of the object, and we'll talk about this a little bit later, actually dictates the way that people tend to grab. And we did a study on that I'll briefly discuss later. So if you want to be very precise about how you rotate and move things, just sort of using your wrist isn't really gonna cut it. So you want to use other techniques. One is the bounding box, where you just sort of have widgets that you can grab to manipulate more precisely. And additionally, when you have things like sort of physical-based interactions, and I know that this class is doing a lot with that, and actually I'm sure that they're doing, I know for sure that it's much more advanced than what we prototyped, and that's actually fantastic. What I noticed in our prototyping is that when you constrain the sort of the problem, when you allow for just movement on certain axes, things feel much more in control. I'm really curious if the people at the sort of working on hand physics also have noticed this. All right, okay, so we've got sort of UI controls. We have manipulation. How about interacting with screens? So we see screens everywhere, displays everywhere. So what we were wondering is, well, how are we going to interact with them on the HoloLens? And the first thing that we really hoped would work is, okay, well, it looks like a touch screen. So how about we just implement various touchscreen-like interactions and see how that works. The first versions of these actually didn't work very well because it was very difficult to know when the hand is actually touching these slates. So it's a little bit hard to tell from these videos, but when you're sort of near, you don't really see your hand at all. We can, of course, render the hand, and of course, in VR. VR is very different from AR interactions. I'll try to get to that in a little bit. But you can't actually see where your hand is in relation to this sort of in relation to these screens. So it can be very difficult to press on things like buttons. So what we had to do is we had to have this cursor that turned into the finger cursor, which we'll talk about a little bit later. So that's one change that we made. Another thing that we learned was that people's hands do not move sort of in straight lines. They actually tend to move in arcs. And we did that by actually sort of recording the finger's movement as someone performed a press and then visualizing it in HoloLens, which was very, very cool. And then from that, we kind of understand, okay, hands move in arcs. So we need to adjust our algorithms to look at things more in spherical or polar coordinates, sort of not in just 2D coordinates. So doing things like pressing, detecting, disambiguating button presses and scrolling is actually quite challenging, but we worked on all of those things. And in general, sort of after you figure out all those tricky things, you can make interactions with 2D content work just like you would interact with a touch screen. I should mention that another thing we learned from listening to people try these prototypes was that when you get very close to a large screen, the visual field of view, the size of it becomes very apparent, and it feels quite small because your entire screen is filled with pixels. So that's something to sort of just keep in mind as well. Okay, so use touchscreens interaction for 2D content. Something that we learned when we were doing the 2D UI prototyping specifically was the importance of, if you want something to be sort of reliable to the point where you can visit websites and type on a keyboard reliably, not just about sort of having fun like in a game, is that it's going to work best if you just have a single point of interaction per hand on the index finger, say. Now, interestingly, even if you have just a single point of interaction, many people don't realize that because when they press with their whole hand, their entire index finger goes in as well. And actually, I remember seeing in some demos, somebody would press with their pinky finger, and that still worked because the index finger also pressed the button. So I actually was playing around with Hand Physics Lab over the weekend, and I was super, super happy to see this example because it's the perfect example of why we chose to do 1 point of interaction per hand. So in the Hand Physics Lab, it's all about sort of understanding and trying many things, a lot like with the prototypes that we did for the HoloLens, and seeing what works and what doesn't. And in there's a keyboard demo, and it's I personally found it quite difficult to type words because all of the joints are basically active or hot. And this is sort of exactly explains why we went with just a single index finger for the HoloLens 2 keyboard and in general for all interactions. So yeah, there we go. Sort of it's always nice to see sort of your ideas or your learnings replicated elsewhere because it gives more validity to them. So that was really awesome to see. So regarding the finger cursor, it's actually something that we spent quite a bit of time on getting the visuals just right. And I wanted to share this really great work by one of my colleagues, David Calabrese, who spent a lot of time working on the shader to show that ring and notice how it gets sharper as you get closer. There's the nice luminous effect and also the visual change of the cursor going green as you touch down. And so just to give you a sense of the evolution of the cursor, and then the final cursor that we actually shipped was a little bit different since it was attached to the actual finger, not projected on the slate. And that works then more generally for buttons as well. I always like to share an anecdote for how these things go. For back when we were developing HoloLens 2, for a while, we were getting a lot of bug reports saying that direct interaction just wasn't working at all. Like it was, people were saying that the system was completely buggy and it just totally doesn't work. And this was at a time where we didn't have any sort of finger cursor or any visual at all. And I sort of knew in the back of my head, I hypothesized that, oh, the reason for this is because we don't have the cursor and it'll all just go away when the cursor's there. And lo and behold, when we finally added that cursor and we got it just right, sort of having it shrink down in size to a single point as you touch and having the shadow and having the convergence of the ring with the shadow, then all those complaints when people thought the entire system was broken, it wasn't just that they were saying, touching the cursor doesn't exist. It's like it was all or nothing, basically. Until that cursor was working, people thought, everything was falling on the floor. So the learning from that is that sometimes one very small thing can make or break your demo. So just remember that. And this is a great example of that. Okay, so I promised I would talk about the way that the visuals or the look of a hologram impacts how people try to interact with it. And I wanted to briefly discuss that, where we sort of had a user study, an elicitation study. So this was not an interactive prototype, but rather we showed people a bunch of holograms and we asked them, how would you move them? And the motivation for that was that we needed to know what sorts of hand poses people would be using when they're interacting with holograms, so that the hand tracking team could get ground truth data. So they would know what poses to record. Otherwise, they're just sort of doing things randomly. So we showed a bunch of people holograms, and we said, how would you manipulate them? And from this, we kind of got several categories of types of manipulation. So one thing people tried to do is they just tried to reach out and sort of pinch to grab. They also had a general sort of thing where they would try to frame holograms. So they'd either pick them up from the bottom or from the sides. And what we've learned is that affordances, or these signifiers, these little blue squares that you can sort of grab, had a very powerful impact in how people tried to interact. So the minute people saw those squares, they would immediately try to grab those instead of the entire object. And if you don't show affordances, then people try to treat the object like a real object and pick it up as they would in the real world. But the minute you show affordances, people try to grab those affordances. And importantly, even if you hide those affordances, people would still reach out for the affordances because they would remember those affordances. So this is actually very useful because you can design sort of these visual handles to be very hand tracking friendly. In other words, you can make them small and sort of encourage gestures that are going to encourage people to pick up the holograms in ways that are reliable. So, and this sort of, I wanted to mention one other thing. People tried to either sort of pinch or sort of, they would actually kind of press them with both hands and try to do that kind of interaction. So this both shows that people try to interact with holograms in very general ways, but also that once you teach them or you show them something, they remember it, and then you can hide those affordances later. So I wanted to share that just as something that's a fairly interesting general thing. Okay, so after we sort of learned all of the many ways that people can interact with holograms, we actually tried to build a prototype that worked for all those different ways. So this is sort of a different approach from having a physically based interactions where you just have colliders and run a physics system on it. We sort of used heuristic gestures to detect all these ways. And what we learned is that that's very complicated, because you can get into these very easily get into ambiguous interaction situations. So for example, if I reach out to try to grab a hologram with two hands, I may be wanting to frame the hologram or actually grab it. And so to fix that, I have to basically add a delay in my system to sort of give time for the disambiguation to run. And it can make the UI feel much less responsive. So this is why we sort of went for the first version with a single way to do something. And basically the learning is it's just very difficult to ship this in a super, to make it work for all those interactions. So that was kind of interesting. But what this prototype also did, this was sort of the first end-to-end prototype that we had, where we showed that you can have the entire HoloLens shell work with direct interaction. So it was actually a really important prototype to sort of prove out our whole idea. Okay, so after we sort of did this, we felt pretty good about near interaction. So I'm going to quickly talk about far interaction. So far interaction is very difficult, I would say. And we tried, and I think the reason for that is because people usually don't interact with things at a distance. So things that are nearby, we have lots of understanding of how to interact with them. But for things that are far away, we don't have a real world analog. So we tried many, many, many different prototypes and techniques for interacting at a distance. I'm going to show you some of those. So many of these are probably going to be things that you have also been thinking about, which I think is always nice. And I encourage you to still try them anyway, but just, I want to share the things that we learned. So the first thing we tried is one thing we tried is finger pointing. So this is the idea where we would cast a ray from your eye to sort of a point just above your finger. And use that as the sort of target location. And this is really great for sort of pointing at an item. But if you have a selection mechanism that also involves the hand, so if you had like a point with a voice, that could work. We have to have something that doesn't rely on voice because people aren't always able to talk. So any sort of thing that involves the hand movement to select, that's actually going to move the finger point. So that immediately you can see how much that location moves when you're pressing. And in general, I would say that what we noticed is anytime we use the targeting mechanism that used the hand joints, that actually made it very difficult to both target and select at the same time, because as you do the selection gesture, the target point ends up moving. And we saw that very much in this example. So here we have a task where we're trying to select the cyan button, and the minute it's like incredibly difficult to target, because the minute you start trying to select, your finger, sort of the cursor moves. I would mention that you could try other ways to select, but it's still going to have the same problem. So if you use some other gestures, some other hand motion to do the selection, your hand's still going to move as you do the selection. And you know, we have a pretty high standard for having this work for fairly small targets. So you're sort of just fighting against the sensors at that point. Here's another thing that we tried. Pretty much anytime someone talks about the FAR interaction on HoloLens, they ask me, well, why don't you just use the wrist? Why don't you just rotate with the wrist like a motion controller? Let me explain to you by using a prop. So people normally think that you point things with your wrist, but actually, most of the time you're using your fingers, not so much your wrist. And if you actually try aiming with your wrist, it's a lot harder than it seems, because you're actually usually using both your hands and your wrist, your fingers and your wrist to move things. And of course, tracking fingers at that level of accuracy is really difficult. So this is why wrist pointing is my favorite example of a technique that everyone tries and then everyone kind of universally realizes is not such a good idea. And I'm super curious if anyone has ever found a wrist pointing technique that works well for them. And again, sort of the way we're evaluating all of these is we have a task, like, you know, press the button that's a certain color, and we use that task to evaluate how well certain things work. It really helps. If you don't have a task, it's going to be really hard to compare and contrast different ones. I would say that this is sort of a laboratory task that isn't necessarily as good as having a real UI. So if you can have a real UI, like a browser or maybe, you know, a keyboard or something, that's even better than a bunch of buttons. All right, I really wanted to show you the flying hands. So this one is a technique that I personally really wanted to make work. So the idea behind this one is that if you're near an object, then you can just reach out and interact with it. But if you look at something and you're far away from it, then a virtual hand flies out to it. And you can sort of do the same, it's the exact same logic, like the code is the same, just the positioning of the hands is different. So what we learned from this, we spent quite a while trying to make this work, is that it works great for certain basically scenarios, things like games. It works great in this demo when you have only 3 objects. When you try to make it more general, and this is why testing your prototypes in situations that match the real product, like the real shell, is actually really important. It can be very difficult to move objects large distances. And when you have many things close together, it's also really difficult to know which item do you fly the hand out to. So while this technique could be really good for like a game in a highly constrained environment, we're building the shell where it's actually really important for it to work more generally. Okay, so now on to the thing that we actually ended up shipping, which was actually shipped, as folks working on the Quest know, in other platforms as well, is something that where the targeting is basically using a combination of a very stable point, which is sort of the head or the shoulder. The shoulder is inferred from the head. And then just the position of the hand, of the palm, basically. So those are 2 very stable points that don't change very much as you do a gesture. And because reliability and selecting small targets is actually important, this is the thing that we ended up going with, even though there's definitely limitations to it that we're aware of. We actually ran lots of comparisons between this and even the head targeting. And what we found is that the ray-based targeting actually works much better for novice users. They kind of understand it much better versus the head targeting, which can take some time to get used to. So lots of time spent on far interaction. In fact, usually I think we spent more time on far interaction than the near interaction, because near interaction went like there was a lot of things that were working quite well. And it was just about refining, whereas far interaction is just a very hard problem. So when things are far away, use hand raise to interact with them. Okay, so I wanted to have 2 more sections here, and I'll go through them fairly quickly because of time, where I'm actually want to show you how we are applying these learnings that we have in tools that we're working on. And the motivation for that, and I've been following Twitter, is that people are saying, and I completely understand where that's coming from, is that there's no really UX standard for AR and VR yet. And there really isn't yet, because like I mentioned, we're still in the Wild West, and all of us are going to be inventing and refining these as we go forward. Literally, probably folks on this call that are listening in on this may invent the next big interaction technique or the next standard. But we need some set of UX controls so that other people can build, HoloLens 2 VR and AR applications. So that's what we've been trying to do in the mixed reality toolkit, is provide people with a set of user controls that, to the best, it's a point in time, work in progress, that to the best of our ability implements many of the instinctual interaction principles that we've learned in our prototyping. So I wanted to quickly go over these, and shout out to Yoon Park, my partner in crime, who has done a fantastic job with most of these slides. He actually has a talk that I've tweeted a link to, and I'll try to do another one after this. A really fantastic talk about a deep dive into MRTK, or the Mixed Reality Toolkit, that really shows you how you can build your applications using these controls. It's absolutely a must watch if you want to get into HoloLens development, or actually development with AR and VR, because the Mixed Reality Toolkit is not actually just for HoloLens. This is an open source project that I actually spent a good part of the last year working on with many of my colleagues, including Yoon. And it's open source, and it's actually cross-platform, which is something that's really awesome about it. So you don't need a HoloLens 2 or a HoloLens to build hand interactions. This is something that works for Windows mixed reality devices. It works for Android and iOS phones. And in fact, Eric Provencher has made a Quest plugin so that you can actually build MRTK experiences to work on the Quest. And the really awesome thing about this is that once you build it for the Quest, if you ever, when you get a HoloLens or you get a different device, you can just compile it and target it toward the other device, and it'll work on that as well. So many of you probably know about this, but just really quickly, here's a sort of a montage of the various UX controls, and there's a piano, like Rene mentioned. So basically, we just take most of those ideas from the prototypes, and we try to package them in controls that you can reuse. With various things like the globe there, that's all in MRTK. And just as a pointer, if you want to see most of the content that you'll want is going to be in the hand interactions example scene. So when you get MRTK, just make sure to download the examples Unity package, and it'll be in that scene where you can kind of pick apart all of the components and see how things are made. So really quickly, I'm going to go over how those principles actually manifest themselves in MRTK. So single point of interaction, that's going to be the poke pointer. I have a link in most of these slides to sort of the documentation that's attached to this for folks that are interested. And so this is going to be that one sort of point on the index finger that's going to dispatch various events based on the type of touchable content that it's near. For visual and audio cues, this is actually one of the big benefits of using the MRTK, is that our visual team and folks around the world have been spending quite a lot of time perfecting the shaders and the visual look to make the things like buttons very responsive to it. So I really like to use the pressable button as an example of that. So again, that's in the MRTK examples package. And you can open up the pressable button HoloLens 2 prefab, which is unfortunately named because it will actually work on any platform. That's something to be aware of. It's just the HoloLens 2 style. So that's an unfortunate naming that folks have given us feedback is a little confusing. So you can open up that prefab and then look at all of the shaders and materials and the logic that actually makes those audio and visual feedback work well. For touchscreen interactions, we have the Slate prefab. Again, it's in the MRTK core package available there to look at. For grabbing, we have a new script in MRTK 2.4 called Object Manipulator, which is a little bit refactored over our old manipulation handler. So this supports near interaction, one two-handed interaction, far interaction. The nice thing about MRTK is that by default, you get far and near for free. If you want to remove the hand raise, you can do that by looking at the pointer profile or looking at the pointer behavior, some pointer behavior controls to remove it from code. So for the bounding box, we have a bounding box. So this is a component that you can just attach to any collider, and then it'll build a bounding box around it. And actually, I should mention that in MRTK 2.4, we have a new control called bounds control, which is like the newer version of bounding box. And for most of these controls, we actually have documentation on our website to show how to actually use these. I also promised, since this is a class about it's actually a course, I wanted to share some tools that you can use to prototype better using MRTK. I would say that MRTK, it's not perfect, but it does have some very useful things that make it good for rapid iteration if you're using Unity. So the one useful thing, and actually what I would say is for any tool that you're working with, you should make sure to reduce the iteration time first. So spend time to be able to work as quickly as you can and also to understand the state of the system. So debug printing, things like hand velocity and so on. I sort of have a script where it's attached to the camera and just prints out lines about the current state. It's my debug info script. I'm happy to I think I can share that. I'm not sure yet, but so yeah, those two things are super important for rapid iteration. So in Unity, I remember when we were going to ship HoloLens 2 without in-editor simulation, and I said, we absolutely cannot do that. We have to build the in-editor ability to move the hand, because deploying a project to HoloLens 2 actually takes quite a bit of time. And this input simulation was revised by somebody named Lucas here on the MRTK team. But the first version was actually written by me, and it's something I cobbled together and said, we absolutely have to ship it. So that hand, I think, is in hand captured actually. So the instructions for how to use this are available online and also up in this slide here for folks that are interested. But you can basically move the hand around, move the camera, and press on things. You can also use different hand gestures. So you don't need to just use that open finger gesture, and that's all available in the configuration. And we have documentation for that as well. So this is a new thing in MRTK 2.4 that's actually very useful if you want to do more sort of articulated or refined or like sort of more precise or richer hand interactions, is that you can actually use the leap motion and it will work. It'll bring up a hand. And I was just testing it out last night. I literally, got my leap motion, which is a much, it's a $90. So still not, it's, still not under $10, but it's much, much less than $3,000. And you can just put the leap motion on your desk and just put out your hand, and it'll bring up that hand there. So this is a really great way to do fast iteration in editor with more articulated hands. If you do have a HoloLens, one thing that I wanted to share, if you don't know about this yet, is holographic remoting. It's a game changer for HoloLens. When I was doing most of my prototyping, I had to do something like this, where I have a Unity project that I compiled to Visual Studio, and then I run on my HoloLens. And that's why we had lots of tools around making that iteration loop faster, because that can actually take like many minutes. And so you want to do something that's much faster. So holographic remoting lets you run an application on your HoloLens, and then you basically hit play in your Unity editor after you've connected it, and you can see your whole scene in your HoloLens. It's sort of the equivalent of hitting play and having a VR headset on, but for HoloLens. So this is super useful. And just a tip, if people don't know about this, is that you can actually connect your HoloLens with a USB cable to make it much more stable. And this is a slide from Yoon. Thank you so much for sharing this, Yoon. But it's super useful, and I want to make sure people know about this. And then one more thing that many people don't know about that's in MRTK, which is something that I personally used a lot when I was refining many of the algorithms, is the animate input recording features in MRTK. So what this means is you can actually, through code or through a GUI, record a sequence of hand joint positions over time and then replay it later on. And this is incredibly useful when you're trying to debug things, because for example, when you have, I remember with slates, I would have people try my buttons on sort of the 2D touchscreens, and the button presses wouldn't work, and I wouldn't know why. And it was really valuable for me I had a command where I would record, or I would have a buffer of the last 30 seconds of hand data. And then I would say, save last 30 seconds, and I would save it to a file, and then load it back in the editor and replay to understand why that person's button press wasn't working. That's incredibly valuable, and it's often overlooked in MRTK. Super useful feature for perfecting sort of various algorithms. It's always useful to gather data. I just wanted to share that we have, for folks who maybe are a little more rusty with their file I/O, we have examples of how to write CSV files or comma separated value files. It's in the MRTK examples package. It's just in there if you search for, I think, CSV or something like that, or user input recorder. Yeah. Okay, so we're coming on this. Gonna try and make this quick because we're coming up on 50 minutes. So Farhan asked me to share with you various challenges and opportunities in this space. So I was going to give you my top 5 sort of opportunities for people that are working in this area to think about. One is FAR interaction. I definitely think that is still a very open problem, a big one. So how to make that easier to use, less effort, and more precise. So I think physically based interactions, like the work that Hand Physics Lab is doing, is super interesting. How do you both allow people to push things around, but also grab them reliably? Leap Motion spent a lot of time on this as well. It's really hard to get right. And then thinking about sort of low calorie or low effort interactions. So how do you make things sort of comfortable and effortless? Sort of still bringing your hand up to target is a lot of work. It would be so much nicer if we can come up with ways to make things easier. Something I care a lot about is having standards for UX controls like buttons and sliders. And then just increasing the speed with which we can iterate in AR and VR. I've been working on a web-based game with my husband, and I'm just so jealous of how you can just modify a JavaScript and then go to your browser and it's already been changed. You don't even often need to hit refresh. It's just so fast to iterate. And I really wish we had that for AR and VR. So just some takeaways at the end. Hopefully I've mentioned to use visual and audio cues as much as possible to compensate for the fact that you're not actually touching anything. When possible, use familiar interactions that mimic the real world. So press buttons, grab things that are within arm's reach. I didn't mention this too much, but AR is actually very different from VR. Basically, for one, you can see your hand, but also the types of things people do are very different between AR and VR. So I remember when I was using VR, I had the same prototype that worked in VR and AR, and I would move things very differently in VR versus AR. I usually in VR would keep things fairly close to me. The minute you go into AR, you start wanting to put things on real objects. So I have like in the back, I have that shelf. I'm putting things on that shelf, the holograms on that shelf all the time. So don't just assume that your VR app will behave the same way in AR. And finally, just I would say just always try as many things as you can. Always be prototyping, and always be thinking and building. That's basically what worked for me with HoloLens 2 anyway. I did want to mention that the HoloLens 2 is actually available for purchase on the Microsoft Store in the US, and I know in Canada. I'm not sure about other countries yet, but just wanted to let people know that it's finally available online to purchase. I know that it has $3,500 is not a cheap price at all, but it is possible. Maybe the great thing about MRTK is that you can as you're working to get grants or to waiting for devices, maybe have one per classroom or something. You can build everything in MRTK without needing a HoloLens. You can do everything in VR with a Leap Motion, or just with in-editor simulation, or with the Quest. So with that, thank you. And I want to leave with a list of resources, various links and stuff and people to follow. That's it.
Wow, thanks so much, Julia. Let's all give it a round of applause, a virtual round of applause and high five. That was an amazing talk, Julia. Thanks so much for taking your time and showing us all these inspirational things and all the lessons learned, definitely. I see some high fives here in the comments as well. So yeah, awesome. Got a bunch of great comments already from folks that loved your talk.
Awesome.
All right, take a breath for a moment. And then we already have the first one raising their hand in the chat window in Zoom here. So we'll promote you to the panelist now, Eldis. And feel free to unmute yourself and please enable your webcam if you're able to, and then go ahead with your question, Eldis.
Okay, thanks. Great talk. That was fantastic. So working with hand tracking, you learn to sort of hold your hands in a certain way, like head pointed at your hands, playing angled piano, or like maybe in claw mode, you know what I mean? But a lot of first timers don't really do that. They'll like hold their hand, try to grab something over here, or like do occludy things with their hand. How do you design interactions or maybe instruct people to do this in a particular way? I'm thinking of Leap Motion specifically. They have a thing that made your hands transparent as tracking quality decreased. And like spending 10 seconds with that told me everything I needed to know.
One thing, so going back to the Minecraft cube, let's see if I can go to it. Here's one trick that I did really early on is I would ask people. So first of all, I noticed that people don't try to interact with things that they can't see. And then I would actually guide them, or I'd position things fairly high, and I put handles in hand tracking friendly locations. So for example, with this cube, I actually had people grab the bottommost corner. I would instruct them to grab the bottommost corner because that's the most, so it's usually the cube would be above their eye level, and that would be the most hand tracking friendly location. It's actually something that's really important that a lot of people miss is they put handles in super difficult to grab areas. So they'll put them on the sides. Actually, for various design reasons, I've seen examples of stuff that we have where on the side is actually okay, but on the top, it sometimes can be hard to grab something from the top, even though we do have that in some of our UX controls. Grabbing things from the bottom, you basically just, I tend to put things near the bottom, and then I make them look like, you can literally design handles to make them look grab friendly. If you don't put handles on things, people will tend to just try to grab it in super non-hand tracking friendly ways. But if you make them very narrow and thin, people will tend to pinch them basically. So that's for the gestures. As far as making things grabbable in the field of view, we actually didn't hit that as much because, again, people with HoloLens, at least, they tend to not grab things that they can't see. I think it's more, again, this goes to AR versus VR. In VR, you see much more, so it's really different.
Yeah, on the DK2 with the front-facing Leap Motion, that happened constantly.
Yeah, so this is super interesting because there's just some problems that are more exacerbated in AR and some that are less exacerbated in AR. I would say mostly the more, but I feel like AR is really hard. But VR is also presents all sorts of challenges. So we don't do any sort of fade out. Again, because you can see your hands, so fading out your hands doesn't make sense in AR. So it's more about designing the affordances in hand tracking friendly ways.
Thanks.
Okay, so while I also make the next person panelist to ask a question directly, we also have Roger and Dennys here from the hand tracking masterclass, which are actually the hand tracking masters, if you will, that are giving these class. And then we also have Eric Provencher here, who did the MRTK to Oculus Quest port. So we have the kind of with Julia, the kind of a hand tracking super group here. And so if you have like different questions, feel free to also come on mute if you want. Let's keep it interactive, right? All right, so next person, Ian, I will make you a panelist, so please unmute yourself and turn on your video and go ahead with your question. Ian McKenzie. All right, let's give him a second and let's look into Slido in the meantime. There are a bunch of great questions on Slido, and one of them, let's go down with the list in the popularity order. One of them is two requests for HoloLens 2. First, for interactions breaks when trying to point down. I guess the hand tracking won't be seen, right? And the second one, would be great to have a touch surface event beyond spatial mesh collision.
A touch surface event, like an event when you've touched a surface? Is that what that meant?
I guess that's what is mean here. Yeah, that's what is meant. Yeah.
I'm taking notes. Thanks for the feedback.
Okay, Ian, you're ready
Hi.
to ask a... There we go.
Yeah, just a slight audio issue. So my question is, with using the HoloLens for a while, it can get kind of fatiguing to have to keep your hands out in front of you or in front of the device in order to be able to register different gestures. As somebody who's worked with the HoloLens extensively and through your testing, did you notice any kind of counters towards that? I think back to with the HoloLens 1, they shipped the clicker with it, so that way you didn't need to always raise your hand in front of you to do the pinch interaction. Do you find any preference of users leaning? Do you see any direction in using a technique like that as opposed to needing to keep your hands in front of you?
I think that this is one of the big challenges that's why I picked up this slide, is low calorie interactions, or increasing the comfort and of interactions and not requiring that our hands are up in front of us all the time. It's something that I'm super interested in researching how to best do that. There are disadvantages to having other accessories. One thing we found when we were running user studies is that people tend to lose their clickers. It's just one more thing that you need to carry around, whereas you always have your hands with you. So it's sort of the tool that you have always with you, which is why it works so well. I've noticed for lower fatigue, like when people do get tired, voice is a great alternative for that. And then also there's actually, HoloLens works with things like Bluetooth keyboards and Bluetooth gamepads, which also can work fairly well. And I'm not sure, okay, never mind. I'm not sure about the clicker compatibility with HL2, but I remember having many bugs that I had to fix regarding the clicker. So yeah, I can't comment on that one, but it's something that we're actively looking into and very aware of, for sure.
Okay, thank you for the talk.
Mm-hmm.
Awesome. All right. Well, I make the next person a panelist. Adrian, please get ready. Let's look into Slido again. And there are actually a bunch of questions which I will summarize a little bit. They all go into a similar direction, about skeuomorphism, or like let's not build 2D UIs, but really fully 3D metaphors. And so let me summarize it. One of them is, I found skeuomorphism, making little things look like physical ones, could help in building an interaction language. And all of these other questions around, like, okay, 2D UIs don't work so well, let's get into the 3D metaphors. And so what's your take on that? What do you think is like very important, like in the, from a design standpoint and an interaction standpoint? You tried out so much, and well, I guess the answer, but yeah.
Yeah, I think that honestly, for 3D metaphors, for things like for example, I think I saw on Twitter somebody mentioned that our file explorer, why is it 2D? Why is the file browser not 2D? And the answer is, like, we're still it's really a time thing. We have there's so much to explore, and I think that we can improve on these things. But when you think about how much work it is just to ship touching holograms, is like literally a question of time. So I would say, like, it's it's a super interesting idea to represent things as 3D objects instead of 2D screens. And I'm really looking forward to what sort of things that you all come up with as well. Let me see if I can think of, from the design standpoint, I definitely am not going to speak about the visual language of HoloLens. I think it's really nice. What we found is that for HoloLens at least, so this is where AR and VR are different, is that you want things that are not pixel heavy. So your core buttons, you'll notice that they're fairly darker colors with more of lighting and luminous effects, not sort of skeuomorphic red buttons. It's not like a big red button that you press. It's almost like a light, and that's for visual comfort reasons, that we don't want to put too many pixels and have people like looking at bright screens all the time. What we found is that having things that are lighter can actually feel better. So that was a deliberate reason to not make those things look like real objects, because again, it's not quite real. It's not quite like the real world. You are still pressing the air when you're pressing a button. So I think we instead went for that more luminous effect that actually worked quite well and was more visually comfortable as well. So.
Yeah, and just real quick, a follow-up question that I also saw on Slido. Are VR and AR interaction designers working together on a standard for hand interactions in the near future? How much are you influenced by VR? And I think that's also a question for Dennys and Roger and Eric. It's like, I mean, that's again the super group here, right? So maybe there's already a standard in the works. I'm just not aware of, but yeah, please tell us a little bit if there's like something like as part of OpenXR or something like that. I don't know. So is there a standard being worked on? Are you aware of, or is it still too early? Are we still exploring all these things and before we can actually have a standard?
My take is that we're still exploring, like we're trying, a lot of this is happening through Twitter. A lot of our communication is through Twitter, and we're all discovering things. I mean, like, it was like 2 weeks ago that Eric showed his teleport gesture. Like, this is all very fresh. I mean, think about how long it took for 2D UIs to have a standard. I would be, you don't want to, like, it still feels like we're really exploring, but for me, I'm trying to communicate and share as much as I can to sort of share the general ideas, and through MRTK as well.
Yeah. Roger, Dennys, Eric, you guys want to add something to that?
Yeah, so I think that in terms of standards, it's very, very early to really cement anything, as the technology is still evolving. Like, just the technology for doing hand tracking, I think, is very different even on the different platforms that are supporting it. Like, if you look at how HoloLens 2 does the hand tracking, it's with depth sensors, and so the quality you'll get, as someone mentioned, touching surfaces, it doesn't work as well as, say, on the Oculus Quest, which uses just optical hand tracking. So when you could touch surfaces, that's actually, the tracking doesn't get lost. So just with these differences in the technology, like, I think that we're still a ways off from being able to cement. And I think MRTK right now is doing a really good job at providing a set of tools that can be used to build robust apps. And I think it's a really good iteration ground right now. But yeah, like, I always see stuff on Twitter and people just share what they're working on, and I think it's great to see the progress.
I love it. Roger and Dennys.
Yeah, I wanted to add one thing about that. Sorry, Roger. The beauty about hand tracking is that there is no more need to have those devices with those all different inputs. Now it's finally a universal input that we have, that we don't need to develop separately for all those different, and thinking, oh, there is a trackpad on that one, there's a joystick on that one, there is those different buttons there. It's basically a universal input system that can be used from then any device, and then the kind of action, interaction, and input system we want to have then basically can be ported to any other headset that supports hand tracking, because it's the only input we need, actually, the position of the finger, the hands, and that can be ported then to any kind of interaction system. So that's finally an opportunity to build such a system which is like completely like independent of the headset and the different controllers, because we don't need that anymore.
Great. Adrian, we did not forget you. Now it's your time, please. Please come off mute and ask your question.
Hey, hello. Can you hear me?
Yes. If you can
So,
turn on the webcam, there we go. Nice.
I can. Basically, I'm sorry. It's just because I'm basically in the sailboat. You see.
Oh
So
wow, man! Wow, that's awesome.
I
Like,
can turn
hey,
on the
I'm on a
camera.
boat for real.
Exactly. So, but sorry, I'm in his live, so you know you don't always find
That
the
is
right
awesome,
place.
man.
So basically, my question is, I'm also like developing for Oculus Quest, where you see your hands at Herzog de Meuron, which is an architect office, and also we are getting HoloLens right now, which is super cool actually. And basically, I wanted to ask first, like, say to Julia, like, thanks a lot, it was a super good talk, and ask her if she has already experience with multiplayer sessions and this kind of collaborative experiences. So, and some tips to give about this.
Yeah, I really am a big believer in multiplayer collaborative mixed reality. I have experience in it. And as for tips, I would say there's various multiplayer technologies that work really well. And to just use those libraries, I guess that would be my tip. I'm a really big fan of it. Yeah, I wish I could say more, but yeah. So I would say there's libraries that are well known in Unity that are, yeah, Eric said Normcore is awesome. So I would look at those existing libraries and leverage the community for advice on those. So talk to people on the Holo Developer Slack or on the expert group for that stuff.
Right.
Cool, thanks.
Okay, so let's promote James here probably to a panelist. Hey, James, did not forget that you raised your hand. So please go ahead and unmute yourself and maybe turn on your webcam if you have and ask your question, please.
Yeah. Hey, Julia, thank you for the talk and for all the leadership in the industry. So yeah, HoloLens has a lot of, HoloLens 2 has a lot of inputs, including, you know, eye tracking. And I wonder, do you see that there's a direct sort of intersection between eye tracking and hand interaction? Or do you see them kind of separate in the like robo-raid style?
I see they're both, they will be better when used together. They're better together. That's what I think. And importantly, the eyes give a lot of cues about intent to interact, which I think is a really interesting future area for us. And it's a really, really interesting area. That's all I can say. I do think that they're, you know, Sophie Stelmach has posted a lot of really good guidance about eye tracking on mixed reality docs, the MR doc site. She's sort of my eye tracking counterpart. We work a lot together. And I would definitely start there. But I do think that they are better together. Yes.
I was going to point out too, by the way, in terms of the standards conversation, that Daniel Beauchamp's work on Twitter also, that Shopify, like American Sign Language is a really great standard to explore, I think, for hand interaction.
I followed, I really liked that, those videos. Yeah, I agree.
Great, great. And James, I saw you also had a question on Slido regarding the occlusion. Do you want to ask it directly now?
Yeah, I guess, yeah, just curious, you know, the system UI in HoloLens 2 doesn't have occlusion of the hand, but there's other experiences like in the playground, the keyboard does. And I wonder if you could just talk a little bit about how the differences in those two experiences might have, you know, delineated the approach somehow.
I gotta say, you are very observant and it's really cool that you notice all these things. That's really awesome. So I would say that a lot of the things like the playground are still kind of like a lot of these are sort of meant to show you the capabilities so that you can understand how things like occlusion feel. So a lot of those are intended to show you many different ways and many different experiences, so that you don't necessarily, so that you can use that to inform your own decisions. Regarding occlusion and the shell, it's funny, AR and VR, like I said, are really different. One of the differences is you can see your hands in AR. So you can see your hands in AR. So occlusion is a really, it's really tricky to do perfectly in AR because you can see your hands, so you notice all the latency. So I guess that's where I'll probably leave that for now. It's a really interesting, really interesting problem that I definitely spent time on and stuff. Oh, Dennys said something, has his hand raised.
Oh, yes, I had a specific question because I think the distance interaction with the two hands you were projecting away to like interact with an object far away was a really interesting approach. I was just wondering, how did that actually work? Was it just a one-to-one clone that was projected there? Or were you using some kind of like laser pointer or instinctual interaction to control those hands? And also, why did you abandon that approach? Why it didn't really feel good? Because I always thought in VR, having those different perspectives, like third-person perspective or being to like control yourself from a different perspective was always something interesting. I wanted to like know your opinion on that part.
I think she's muted.
Julia, you're still muted.
Yeah,
Can you just unmute yourself and then start again with the answer?
Yeah, I just realized that I stopped sharing my screen, but the general approach, let me see if I can share it again. This one. It's shown in the bottom row, middle column. And so basically what I did is I'm putting the camera, I'm just moving the camera basically. Like the hands are all represented relative to the head. So if you move the head around, you can do things like scale, you can scale the body as well, like all sorts of very interesting things. The reason that we stopped, or that we didn't, so abandoned is a strong word. We didn't ship it for HoloLens 2 because it's one of those things that can work great in specific scenarios. So like for a game where you have a very constrained environment, it can probably work good. But in the shell, when you might have many windows near each other, it can be very difficult to know where you should put that human, especially because when you have content that's really far away and large, how big do you make that human? So then you need to say, determine what size the human should be, which is tricky in the general case. So maybe if you have a giant screen, you can say, okay, the size of the human should be 1/3 of the width of the screen. But then if you have two screens next to each other, then it gets ambiguous. So we basically projected array. By the way, for the positioning, I projected array from the head. There's maybe other ways you can do it. And it was also quite difficult to move, like if you had an object far away and you wanted to move it to the other side of your room, determining how to move it, like the logic for that, you'd have to switch targeting mechanisms if you wanted to grab and move something far away. And then people would have a really hard time understanding or predicting where those hands will fly out to. So we would you want to, once we had a task with a bunch of buttons, somebody wants to press a button in a certain location. It was hard for them to get the hands to fly to that exact location when there was many targets nearby. So that's why we ended up going with the shoulder array basically. Well, that's why we didn't do that's why we stopped eventually on the flying hands. Also, we got a lot of feedback that people found them creepy. So I'm not sure if that can be fixed with visual design. But I should mention that too, yeah.
And regarding that, we actually also have a similar, kind of follow-up question on Slido. What kind of telemetry systems worked best to collect data while testing prototypes? Basically, how did you run like user studies or things like that to test it out? Maybe you can go a little bit into detail on this one.
Yeah, so to be clear that this is not me making statements about like how, any sort of privacy or telemetry in any of our shipping products. This is, so personally for prototyping, Simple is better. So like things that I've seen, you know, when I was doing my PhD, also in school, just writing things to a CSV is very effective. So a comma separated value file that's just on the device works well. And usually you can maybe get sort of, if you want to send your study to many people, then using something in the cloud can work better. But I usually was just making do with writing to disk, honestly, and just keeping it very simple.
Okay. Another one from Slido, iteration speed. Unity 2019.4 supports pressing play without reloading the scene, and domain makes it instant. Would be great to get MRTK support for that. Maybe that's some feedback to take.
Yeah. What was the second part? So 2019 scene play without scene reload.
Yeah.
What was the second part?
Well, it seems like MRTK does not support that, kind of. And
okay, I'll see
it would be good to get MRTK support for that, I guess.
Cool.
Yeah, and then great question here, of course. I'm new to development, Unity and HoloLens 2 in general. Do you have any suggestions on great learning materials to get ramped up on HoloLens 2?
Yeah, I just tweeted a really good getting started guide for that one of my mentees or someone I mentored posted. So we Microsoft actually shared publicly the videos from MR Dev Days that was happening this year, and that actually has a lot of really good talks to follow. And in particular, there's one called Introduction to MRTK Unity, which is a really good place to start and follow along with. Also, we have getting started guides from MRTK, and there's also some step-by-step guides on MR docs. But I would probably start with the intro talk. And also UnParks, UX building blocks, which I just tweeted, and I'm probably going to tweet again a list of resources.
Nice. Yeah, that sounds like a great idea. By the way, if you're not following Julia on Twitter, you're missing out. And her handle is Julenka.
Yeah, I'll put it on the screen share. Julenka.
Exactly. That would be great.
Julenka. Yeah.
Yep. All right. Let's maybe take 2 or 3 more questions, and then we'll right at the time, actually. You mentioned about ambiguous interactions for near interactions. How useful are uncertainty representation in interaction models? Are they implemented in HoloLens 2?
Oh, that's a really interesting question. I obviously can't. I'm not going to be able to speak to specific, implementations, but I spent a lot of time in my PhD studying ambiguous interactions,
right.
And I think for HoloLens, it's definitely very, very useful and a really interesting area of research for opportunities for folks to look into, because you have a lot of signals from various sensors available to you on the HoloLens. So that's all I can say. Yeah.
All right, let's take this one as well. Can multi-cursor work? And how feasible is it for piano chords, for example? What can we tweak in MRTK to make this work better, if anything? Multiple cursors?
Yeah, I think that the really good, I'm actually, so the playground on HoloLens 2 has a piano that has all the fingers active. So I would just recommend just trying it out. I think it can work, and it's sort of just for reliable interactions. You want just a single point in order to maximize sort of confidence. But if it's more about having fun, or if it's a skill-based thing, you can always try to have multiple cursors, but it just requires a little more time and practice, I guess.
Yeah.
Can I add a point on that? Yeah, just on the
topic of tracking the other fingers, I've noticed personally, and I've mentioned this on Twitter a few times, that when you have your hand out, your thumb, index, and middle finger, those are usually well tracked by optical systems, but your ring finger and pinky are usually pretty poorly tracked. And you can find, trying the playground, that your pinky has a really hard time accurately pressing notes. This is on the theme of like, you know, we're evolving standards according to the technology, and I think that right now, like, this is not something that we should really like focus on, especially with these fingers. So I would say focus on those 3 fingers on each hand. That's my goal.
Roger, Dennys, anything to add, like from the VR standpoint?
Yes, I just wanted to like point out, I really like that Julia highlighted that having an approach to prototyping that includes visual and sound feedback is very important before you can judge how good a prototype is. Like just with the cursor example she gave, just adding that cursor made the whole difference between something that felt completely buggy to something that felt right and intuitive. So yeah, we do the same approach usually. For any prototype, we find the right balance between functionality, the feeling, the visuals, and the audio, so that it really, we can judge, does it feel good? Is it something we can push further, or do we need to rethink it from scratch? I really like that it was really highlighted in the presentation, because it's something really important in any kind of VR design or AR in general.
Yeah, I wanted to mention that something I really liked about the Quest teleport that Eric did was there was a sound when the teleport was started and ended. So like those little details actually make a big difference. People usually don't notice them, but they make a big difference.
Indeed, indeed. The details matter the most, right? And they take most of the time in the end to implement. So we're a little bit over time here, but let's close with one last question. We cannot go through all of them, but look into Slido, and again, Julia and all the other folks you mentioned, like on Twitter and all other social media. So I guess you can connect there as well. But one last question, which I think could be a good closing one. If you had to do it all again, what would you do first? And let me add, what would you do differently?
Oh my gosh.
Yeah. Put you on spot here.
What I would do first is I would maybe I would start doing sort of MRTK first. I actually did most of these prototypes before MRTK was really evolved, and so we ended up, you know, doing all the like it was like catch up. So MRTK was, you know, architected for HoloLens one. I mean, not for HoloLens ones, architected to be super general. But I would start sooner to take more. In the end, we ended up like I had to redo so much of the learnings into MRTK. So I would start prototyping in a shared system first, and also then other people would benefit from all the rapid iteration tools. What would I do different? Well, I don't know. I mean, so many things. I guess I would. The FAR interaction is really really tricky to get right. So it's almost a question. You know, if we'd spent even more time on it, would we have landed on something better? It's really hard to know. Right. But I think that I don't know. I'm really happy that we were able to ship something that people, you know, liked. There's always things that you can improve. So
right.
Yeah.
Great. Any a few last words you want to share with the group here before we wrap it up? Like any like recommendations or like some tagline you want to hit here?
I'm gonna try to share as many resources as possible. I really love that we have this community here. So I'm really hoping to continue seeing things on Twitter and Slack and Discord. It's really awesome to be a part of this community. So thank you for having me. Yeah.
Well, thank you for this amazing talk and taking your time for enlightening us with all these wonderful experiments and lessons learned and all that good stuff. Really appreciate that you took your time out of the day and shared that with us. All right. Thanks, everyone. Thank you for joining us. We're a little bit over time, but that's good. 5 minutes. That's okay. So again, thanks so much, Julia. Thanks, everyone, for asking these great questions, joining the discussion. And well, see you next time, hopefully. And bye-bye. Take care. Stay healthy and have a great day.
Bye.